Okay, problem 8.10. Consider the function f equals 1 minus the cosine divided by 1 plus the cosine. This function is even, obviously, because we have f of minus x is 1 minus the cosine of x, because the cosine is even, 1 plus the cosine of x, right? So it's even, and f at 0 is 0, right? Because this is 1, let's see, so this is, yes, so this is 1 minus 1, 0, divided by 2, 0. So its Taylor expansion up to 7th order will be a times x squared plus b times x to the 4th plus c times x to the 6th plus small o of x to the 7, because even functions have Taylor expansions that only have even terms, right? In order to see this, you have a Taylor expansion of a function that's even, and you compute f of minus x, you should get the same the same expansion, right? So you had f prime, this is what is it's what, f at 0, right, plus f prime at 0 times minus x plus the second derivative at 0 divided by 2 times minus x squared, and so on and so forth, right? But if this has to be equal to f of x, then this f prime at 0, right, has to be equal to minus f prime at 0, right? Right? So this is f of x, this is f of minus x, right? And you compare these two expressions, they have to be equal because this function is even. So this is equal to this, and this has to be equal to this, right? So this means that f prime at 0 has to be minus f prime at 0, okay? Which the only way it can happen is that this is equal to 0, right? And this is the same for all odd terms. And as you can see, this doesn't happen for even terms, because x to an even power, minus x to an even power is the same as x to an even power, right? Okay. So so we have that f of x has this expansion up to 7th order, right? And now we have f, we multiply it by 1 plus the cosine, so we have 1 minus the cosine is equal to this expansion times 1 plus the cosine. So using the Taylor expansion of the cosine up to 7th order, we need to find the coefficients a, b, and c. Okay. So again, so the cosine is 1 minus x squared over 2 plus x to the 4th over 4 factorial, which is 24, minus x to the 6th divided by 6 factorial, which is 720, plus small o of 7x to the 7, right? So then we have 1 minus the cosine, so 1 minus the cosine is going to be 1 minus this, and then we have x squared over 2 minus x to the 4th over 24 plus x to the 6th over 720 plus small o of x to the 7, and then we have this f times 1. Let me write first, let's see, 1 plus the cosine, right? And 1 plus the cosine, this is going to be 2 plus, 2 minus 2 minus x squared over 2 plus x to the 4th over 24. And then because f, the first term in f is going to be x squared, and we want to get how to say this, that we want to compute this up to order of x to the 7th. If we include the term x to the 6th and we multiply it by x squared, you get x to the 8th. So then the next thing is small o of x to the 5, and when you get multiplied by x squared, you get small o of x to the 7. Okay, so this is going to be what, 2 times a squared, right, minus a divided by 2x squared plus a over 24 times x to the 4th, and then we have b plus 2 times b x to the fourth minus b over 2x to the sixth, and then the rest now is x to the 4, x to the 4 is x to the 8. So that's is what is small o of x7, and then so what the last term that we have is 2 times c x to the 6, right? And the rest is small o of x to the 7, right? So let me erase this. Okay, so now we have these two expressions, and we know these two have to be equal to each other, because this expression has to be equal to each other for every value of x. That means that the only way that we can equate these two things is that the coefficient of the polynomials the coefficient for each term in the polynomial for each degree is the same. Okay, so we have to collect terms for in terms of x squared. So then we have 1/2 in the left hand side is equal to 2 times a minus this is x to the fourth and x to the sixth, 2 times a, and that's it, that's 2 times a. Then we have in x to the fourth minus 1 over 24 is equal to minus 1/2 of a plus 2b, and then we have 1 over 720 is equal to 1 over 24 times a minus 1/2 of b plus 2 times c. Okay, and then you have the system of three equations, 3 linear equations with 3 variables. So this is easy to solve, right? So this is a is actually 1 over 4, right? And then we have 2 times b is minus 1 over 2, minus 1 to 4 plus 1/2 of 1 of a, which is 1/8, and this is 3 over 24 minus this is equal to 3 over 24 minus 1 over 24 is 2 over 24, or equals 1 over 12. So implies that b is 1 over 24, and then here we have so c is going to be 1/2 of that's 1 over 720 minus 1 over 4 times 24, which is 96, and then plus 1/2 of b, which is 1 over 24, which is 1 over 48. Right, so if you compute all this, what you get is 17 over 2880, right? This is c. Okay, so that solves the question, right? Now we have the Taylor expansion of this function using the terms of the cosine without having to compute derivatives.